Hello, I've said a lot about dark energy model, but not everything. So here we are, at this point, a computer model for the entire galaxy, a galactic model of dark energy for all types of stars in the galaxy. There are different types of stars in the galaxy: smaller, medium, larger, and very large. The presented model applies to all types of stars. I will use program Matlab. You can choose one of the programs: MatchCAD 15, MatchCAD Prime 10, SMath. You can choose your preferred version. Skip this video and choose another episode with preferred program. Here are the online links to the files. For all model versions, one link is enough to download the file, zip archive. It must be unpacked on your computer's hard drive. After unpacking the file, the program directories will be available. The appropriate models are contained in the folders. One link is enough. I prepared several copies. If one service stops working, you should choose another one.
Przygotowałem kilka, tak na wszelki wypadek, gdyby któryś serwis przestał działać, no to jest drugi link czy trzeci. Wystarczy sobie skopiować i pobrać.
On the left side, we can select the folder with the files, Matlab folder. On the right side, we open the folder, Dark Energy 11 Galaxy. There are several files inside.
Należy także uruchomić sam program Matlab.
The Matlab program has already been launched. On the left side is the folder window. This file is the main model file, Dark Energy 11 Galaxy. We will run this file. The galactic model has been launched. Comments start with a % sign. The model name is located here. Dark Energy Model. Author, my name and surname. A brief description of model is below. These two commands are used to clear computer's memory. These are Matlab commands. The clear commands clears the RAM. Unnecessary variables are removed from memory. The second command, CLC, clears the command window. It removes unnecessary information. The work environment is clean and ready for calculations. The main program is divided into functional blocks. This is the encapsulation process. The entire program code was divided into several files. These files are called and run in the proper order. The file name entered as a command in the main program window causes the execution of that file. Here, on the left, you can see these files, folder window. In the main window, we create commands for all files, except the first file. Only one file will be run, G variables. This file has been launched. A new tab has appeared at the top here. First, we need to declare the number of layers. Number of solids. We've set up 1,000 layers for each star. That's more than enough. We must declare the speed of the light, next, the gravitational constant, mass of the Sun and radius of the Sun. The mass and radius of a given type of star are related to the mass and radius of the Sun. Look here, a table G-type. I run this matrix. Data comes from the internet, publicly available astronomical data. Data comes from Wikipedia. The table lists the spectral types of stars. The most important data are the columns containing the star's mass value and the star's radius value.
prostu przepisany.
The mass of star is recorded as its relative mass. The radius of star is recorded as its relative radius. This is Matlab style.
W taki sposób, jaki lubi Matlab. Tak? W sposób właściwy dla tego języka, dla Matlaba. No i poniżej tutaj
The value of mass, radius and volume are stored in the table stars. Look here. In the programming loop, the mass, radius and volume are calculated first. Mass value is calculated at the beginning. It's the mass of the sun times coefficient, multiplies of the mass of the sun. This parameter was stored in a table G-type, first column, P, index of table row, 1, index of table column. The radius R was calculated similarly. It's the radius of the sun times coefficient, multiplies of the sun's radius. This parameter was stored in the table G-type, second column.
Kolumnie drugiej, na pozycji drugiej.
From this data, the volume can be calculated. V base volume. 4 thirds pi r to the third power. The calculated variables are saved in the table stars.
Oczywiście w odpowiednich kolumnach.
The first column contains the mass of the star. The second column contains the star radius. The third column contains the volume of the star, physical parameters of the stars. The value of the basic physical parameters. We remember radius, surface area, volume, mass of a body, gravitational acceleration. Note, here are the calculated parameters. File, G-base gravity. The comment has been deleted, so the file can be run. What is inside the code contained in the file?
Zamknięty, enkapsulowany, a my przecież chcemy zobaczyć jego kod. Dlatego go uruchamiamy tutaj i zauważcie, pojawił się
Another tab has appeared. New variables have appeared. Some physical parameters. Declare variables at the beginning. The program reserves RAM. Now the program runs faster and more stable. The data table does not need to be created from scratch each time. And max number of rows, and max equal 1000. P max number of columns, 7 types of stars.
I odpowiednią liczbę kolumn, czyli tyle pozycji, ile typów widmowych gwiazd. Kolumn tyle jest, ile typów widmowych gwiazd. O proszę.
I have temporarily cleared this construct except variable declaration. One of variables looks like this. All data cells are initial filled with zeros. Here, I have already enabled the calculations. The appropriate parameters value are loaded from the table stars. Table stars was created earlier. The average density of the object, row, is calculated. Next, the radius increment, delta r, is calculated. This is the thickness of a single layer. Notice that the star radius value has been loaded. Delta r will be calculated. The program already has the parameters set for the selected star type. It is now possible to calculate the parameters of thousands of basic solids. From 1 to n max, calculations performed in a loop body. The radius is equal to the number of layers multiplied by the length of a single layer. The calculations are very similar to those for a single model. Next is surface, volume, mass, gravity acceleration. All parameters should be saved in memory. For example, one variable is displayed, ray, for 7 types of stars.
Dla 7 tutaj kolumn, bo jest 7 typów podstawowych widmowych gwiazd. Dalej.
As before, the volume and mass of the layers must be calculated. A drawing of a star, the layer parameters need to be calculated. The layer parameters are included in file gshell. Here, as before, variable declaration at the beginning. Calculations must be performed for all types of stars. Therefore, there is an outer loop P from 1 to P max for 7 types of stars, calculating the volume and mass of the layers. The internal loop should look familiar: larger ball minus smaller ball, n minus 1. For example, one variable is displayed, vshell. It's look like a zeros, but it's the power of E27. Last rows of this matrix. Matlab remembers several places. These are not zeros, but some small values. Matlab specific convention. Everything is okay and working properly. Similarly, the gravitational force must be calculated for subsequent layers of the object. We remember that the gravitational force is the gravitational acceleration of the inner sphere times the mass of the layer. The gravity parameters are included in the file gForce graph. Here at the top, the force is calculated. The calculations of force were performed from the inside to the outside, from second position to the last, n max. Why do we start the iteration from the second position? The mass value is loaded from the table mshell, the proper row in the table and the proper column. Gravitational acceleration for the internal sphere, n-1, value 1 smaller. Therefore, the loop should be started from the second position. Gravitational force is the product of gravitational acceleration and mass. The force value of layers should be summed. Initially, force calculations were performed from the inside out. Finally, the sum of the layers, from the surface of an object to its center. Here, from nmax minus 1 to 1, the internal loop performs the summation operation. The gravitational force of layer n, that is the gravitational force of this layer, plus the gravitational force of layer n plus 1. The force of layer n is the sum of all previous layers. On the right side are the variables, calculated variables, physical parameters. Variable F graph, this is the gravitational force calculated just now. We should click on the Run button, the appropriate parameters appear. The numerical results are displayed here, at the bottom. The force acting within a star have been calculated, especially the force acting on the stars of all types. It is now possible to calculate gravitational pressure. The force value of the layers is known. The surface area of the layers is known. Definition of pressure. Force acting on the surface area. Pressure parameters can be found in the file gpressgraph. This is place where pressure is calculated. It's very similar to the pressure for a single object. The variable S takes on the value of the surface area of the sphere. The variable F takes the value of the force of the selected sphere. Pressure is a force acting on the surface. The pressure value should be saved in the variable press. The central element cannot be calculated. The pressure value in the sphere is very similar to the second element, layer 2. The pressure value is copied to the first element, the central sphere. The error value will be small, which is why I could do it this way. Pressure calculated, all layers for all objects, and new variable appear, press. Pressure calculated for all layers and for all objects. All necessary parameters are known, pressure and volume. Energy definition, pressure times volume. First, we calculate energy of the layers, E graph. Finally, we need to sum the energy values for all layers. The gravity parameters are included in file G-force graph. The gravitational energy for all types of stars. The variable V takes the value from the table V shell. The variable P takes the value from the table press. Energy definition, pressure times volume. The calculated energy is saved in a variable E graph. Here, the summation operation is performed. It is a simple summation. That is all. Here, below are some additional parameters. Result presentation. Gravitational energy. Dark energy, it is gravitational energy with a minus sign. Mass equivalent to gravitational energy. Here is Einstein's equation, but rearranged. Dark mass equivalent. That's why we need C. At the beginning, the variable C, speed of light, was declared. Star mass from the table stars.
Pierwszej kolumny tabelki stars obliczany jest później
1% of stars mass.
Gwiazdy, czyli ta masa podzielić na 100, no to jest 1% tej masy. No i wyznaczany jest na końcu.
The percentage factor is the mass equivalent divided by 1% the star's mass.
Tutaj jest, że ta ciemna masa MD podzielić na ten proc 1, na ten 1% masy. I zobaczcie tutaj oto wyświetlenie.
The calculation results are presented here. Gravitational energy for each type of star.
Dla każdego typu gwiazdy widmowego osobno. Tak? Każdy typ widmowy gwiazdy ma osobny wynik. Podobnie z tą właśnie ciemną.
It's similar with dark energy. Next is the mass equivalent. The mass of the stars is copied from the table stars. Next is 1% of the star's mass and the percentage factor, all parameters in numerical form. It is now possible to estimate the amount of dark energy absorbed by entire galaxy. All stars of a given type absorb a certain percentage of a dark energy. The sum of all types allows us to estimate the total amount of dark energy lost in the galaxy. Table from the internet. We need data from the last column.
Każdego typu gwiazdy osobno, a teraz przechodzimy do sumowania tego wszystkiego.
The total result is included in the file G-Galaxy. Percentage distribution of stars in the galaxy. Data copied from the internet. Data from the last column. This parameter allows us to estimate the number of stars of a given type in the galaxy. We need to declare the data here. The variable ng is the estimate of the total number of stars in the Milky Way. Some astronomers estimate that there are only 100 billion stars. This parameter can take different values. 150 billion, 200 billion, 300 billion. Probably the most accurate estimate of the number of stars in our galaxy is 400 billion. Therefore, the variable ng is set to 400 billion. You can change this value if you want. This parameter is only estimation. The final result of dark energy is also estimate. This is an estimate of dark energy in the entire galaxy. This is sum of dark energy for all types of stars in the Milky Way. All operations are performed inside a loop. The variable prods copies the value from the table gprods. The variable num is the actual number of stars of a given type in the galaxy. The total number of stars is multiplied by the percentage factor for stars of a given type. This is the actual number of stars of a given type in the galaxy. The variable dark E takes the value of the dark energy for stars of a given type. The same applies to the variable dark M. Each type of stars has a specific energy value. Now we need to add up the partial results, declaring variables and setting values to 0. Sum of partial results for entire galaxy. The results are presented below. Here are the final results for the entire galaxy. The Milky Way absorbs this amount of dark energy at any given moment. Sum of partial results. Similarly, for mass equivalent. This is a total result for an entire galaxy. The dark energy for a galaxy can be calculated, but the result is just an estimate. We need to be aware of this. The Milky Way is absorbing dark energy at every moment. Smaller stars, larger stars, all stars. The rest of the objects are not included in this model. The calculations for the black hole were performed independently. Object Sagittarius A. You can sum the results of both simulations. It won't change the total result significantly. The total mass of stars in the galaxy is very large. Stars are the main power of the galaxy. I'm sure that this model can be improved in the future. Small improvements to the model can significantly improve the computational results. But that's the limit of what I can do. The maximum I can do right now in the dark energy model. Thank you for watching this episode. Bye!
Cześć!